observations, facts, and possible conclusions, which I go through once in a while at Oracle to find out what's next. Now, why would I do this? Because my name is Markus Michalewicz, and I run Oracle Database High Availability and Scalability Product Management, as well as MAA, Maximum Availability Architecture Product Management. And as my PM team is responsible for all these products, we regularly, go through the market, speak to our customers, that is you, speak to our partners, that is also you, and try to find out, what's going on in the market, try to evaluate market trends. We try to see what analysts, Gartner, IDC alike, others as well, provide as far as data and facts is concerned. And then we try to draw conclusions out of it, just so we can maybe influence the right development in our product. In our particular case, in my PM team's case, that would be the Oracle database. Now, this is the ideal scenario. Sometimes we have a little bit of a different approach, and you can appreciate that one as well, because eventually what happens is someone in Oracle, normally, our development teams, and then people like Larry or Juan Loiser or Andy Mendelson, they all have ideas as where the database should be going. And then these ideas would be floated, and eventually they come down to product management for product management to look at these ideas and find data either confirming or negating the idea, and then we can go from there again. So the task of looking at data, looking at market trends, and then making some suggestions is one that is very familiar to PMs in general, and so to me, and that's why I suggested to various conferences, and thank you, Groundbreakers, for accepting this session, that I would like to share some of those observations that I've made. Clearly, I want to say this in the beginning, I cannot share all the data that has been used or will be used to define or, to see what Oracle database is going to do next, because some of the data that we use is internal data and we use it only internally, but some of the ideas that we are considering and some of the data, therefore, I can share, and this is what I'm doing. I have the habit to do this once in a while, so if you follow me on LinkedIn, or you look at my slide shares once in a while, typically in the beginning of a year, that's why it's called 2020, I summarize some of the observations we have made and some of the trends we have discovered for the upcoming year, normally after Open World in September or October. So last year, Open World was in October as well, and 2019. And so I was planning to provide a LinkedIn article, hence a LinkedIn remark, to talk about 2020, the year of change. But by the time I had gotten around to it, and 20C was available as a preview on the Oracle Cloud, the other change in 2020 hit. So therefore, we do it now, we do it for the half year, but as the other change also postponed some of the development that I would have otherwise suggested, perhaps it's a good time. With that said, let's quickly go into medias res. And before I can do this, I need to make you aware that I'm part of Oracle database development. As such, I have to show you the safe harbor statement, which basically says that even though I'm talking about it, in this particular case, I'm talking about some of the decisions we may have made, and some of those will be future looking. Even though I talk about those, don't make them part of your decision making. Oracle may decide to not release some of those ideas, to change the product, even though I've stated it to be differently in this presentation. So this is one part. But I have to show you another safe harbor statement, because as I outlined in my little introduction, these evaluations, these observations, and the concluding results, meaning to say the possible conclusions, they are largely my own opinions only. I do not represent the opinion of Oracle in this particular presentation. I do share some of the things we have done in Oracle, and some of my conclusions and suggestions may have influenced the Oracle database or the products my PM team is responsible for. But in the end, these are largely my opinions, and I'm no better than anyone else in doing this. So that's why the presentation will go through some of the data. I will also explain what process I followed to perhaps come to some of these conclusions, so you can do that too. And as you do it, maybe you can answer the questions, what's next for you, for your product, for your company, for your customers. So I hope this will be an enjoyable 45-50 minutes. during which we will discuss the following: some observations, some data and facts. Data and facts are different from observations, and they're also different from trends, which we will speak about in a few minutes. And then possible conclusions out of these data or these facts, based on these facts, hopefully. And then we look into what's next. What's next is then a little bit more open-ended. And as Miguel said, you can ask me questions in the Q&A. I'm not so sure I can always answer, as pardon me, I have to present here, but I'll try my best, or even after the presentation, we'll come back to it. And last but not least, we will have a summary. So with that said, let's go through some of the observations. Pardon me, 1 second, please. Some observations that I have made over having been a PM for quite a long time. I've been with Oracle for 20 years, a little bit more than 10 of which, actually 14 of which nearly, I have been a PM in various roles. I was a PM for Oracle Clusterware first. I then took over Oracle RAC product management, and eventually I'm now, together with my team, responsible for all the high availability and scalability products in the Oracle database. And as I have been doing this, and as you can imagine, I have gone through some observations and I've drawn some conclusions, and some of which I found to be repeating. And that's what I want to share with you. Because many of us believe that the IT market is actually constantly innovating, and it's a straight line. And if you look at it overall, and to a larger extent, that's probably even true. Depending on how you look and where you look, you clearly get the impression that this is probably correct. Let's start with the mainframe. And I know there's other computer history that we may be neglecting here, but I try to tailor to the crowd to which I'm presenting. So I think maybe starting with the mainframe, some of you may have lived through this, some of you may have just been born, some of you may have not been born as yet, but starting with the mainframe seemed to be reasonable. So the mainframe set a certain standard way back in the days, and it was actually a good, and if not the highest level of innovation at the time. Now, over time, we got more solutions. The next one after the mainframe was the PC, and that later on introduced the client server. But client server then went over to go to the network computing era. And this one was a brief one. I don't know whether you remember those, but you will see the network computing symbol and era 2 more times in this presentation. So maybe then you can remember, or maybe you can look it up during this presentation then. And the network computing era was actually followed very swiftly after by internet computing. It may not have been a few years. Clearly, in the hindsight, you can say it has only been a few years. At the time, it looked perhaps longer, but in the greater scope of things, spanning 50 years here in this little slide, it was shortly thereafter that internet computing became very famous. And I'm sure most of us here today remember that time. I remember it very vividly, and it was first a buzzword. I remember my parents saying, "Oh, what is this internet? We don't need that." And I guess you remember that too, because internet, unlike other technologies that I've spoken about, affected not only the enterprise customers, but also daily consumers, and still does today. Staying with the enterprise customers, after the internet computing, what has come up was grid computing. And grid computing, in hindsight again, is probably more of a transient period or era. It was very brief, and not every customer has, not every vendor, not every company has actually picked it up. There was a fair amount of companies who tailored to grid computing in America, and specifically around Oracle. I remember Oracle to be one of them, and Dell Computing, Dell Systems at the time, because Dell had produced these smaller computers which tailored very well to the idea of setting up a grid out of smaller computers, even though, as the picture shows, and it's not a Dell picture or an Oracle picture, so thank you and kudos to whoever posted this on the internet. Clearly, the grid computing idea was so that you could combine various compute resources in the grid. You could have supercomputers, you could have PCs, laptops, but also databases as a resource itself, and that may have been considered a hub within the grid then, so were the supercomputers. But Dell and Oracle, hence the picture, kind of tailored to this environment. We had actually a grid initiative at the time, because databases and Dell worked hand in hand, because Dell had provided the smaller computers that then could run Oracle for example, in a grid. Until today, the basis for Oracle real application clusters, the grid infrastructure, has its name from that era. Grid infrastructure was invented, designed, and released during this era, and hence you see why we call it grid infrastructure, derived from the grid computing idea. As a PM, I'm not so sure I would make this decision one more time. In other words, perhaps it's better not to pick up the era name and put it in the product, because shortly after the grid computing time, transient time, as I said before, cloud computing was developed. And cloud computing took over very swiftly. Similar idea, really, you know, decentralized computers, resources, networked with each other, reachable via the internet. So this is how this developed overall, but cloud computing really replaced eventually grid computing to a larger extent. There's still some of it around, which brings me to my next picture. Because the IT market really develops in waves and cycles. It's not a straight line as it may appear to you, as shown here before. If you want to show the level of innovation, that was the one axle. Yes, clearly this is a straight line, but this straight line had some bumps if I would look into the detail, and that is what this picture tries to illustrate. If you look at the market and how it came from the mainframes towards the cloud and perhaps even beyond, then what you will find is that it develops in waves, or I call it cycles, and multiple cycles then go and form an upward spiral, as you can see here. And as you go through this development, after every cycle, you will find there's more innovations and more solutions, more innovation and more solutions. This is not to say that the previous cycle and the result of the previous cycle would have vanished. Sometimes they do, but in the end, and that's why the cycle is a little bit in a spiral, or forms a spiral, because in the end, after all these cycles, you end up having more innovation and more solutions. The other thing is that these cycles are important because sometimes the market waves between certain beliefs, certain trends. And the one trend that I have illustrated here and walk you through, just to show you the full dimension of the picture, is the wave or the waving between centralized approaches and decentralized approaches or waves. And please apologize, again, this is a summary, it's a high level one, so there may be some inaccuracies which are unintended. And yeah, as I said before, this is my interpretation. You may have a different one, but I think you could relate to what I'm showing you. Starting again with the mainframe, clearly the mainframe was a centralized system. You know, every terminal connected to the mainframe, and the mainframe was running the work, until client server came in, because client server, even though not fully decentralized perhaps, they were very much more decentralized compared to the mainframe, because now the clients could actually run some work, and that work didn't need to be run on the server, let alone on the mainframe at the time. Shortly after client server, we came to an era that I mentioned before, the network computing area. Interestingly enough, the network computing area, however, was a little bit more centralized than perhaps the client server. And the reason being is that the network computer that you had on your desktop was a small device, not a lot of disk space, not a lot of RAM, because its intention was to boot a minimal operating system and then connect to a central computer over the network. And that central computer may not have been a mainframe anymore, and it may have been more than one computer, but in the end, you had a finite set of resources reachable via the network, and your front-end computer was merely your portal, your door into that network, so it didn't have a lot of power in itself. And so it was more centralized than client server, but it was also very transient, because shortly after network computing, as I said before, internet computing came along, and that clearly was more of a decentralized idea. In internet computing, everyone who had a PC, who bought a PC in the client server era, now found good use for it, because you could buy your 14,400 baud modem and connect your PC to the internet. And that's what we all did at the time, I suppose. And so we connected multiple computers to the internet. And I'm sure you remember all these programs where people developed interesting ideas using your computer to calculate something and return the result back to their computer or a centralized institution. So internet computing was really a decentralized approach compared to all the others. But you also see now, where I said before, that after every cycle you end up with more innovation, because now you have gone through one cycle from centralized to decentralized, but you also have 4 solutions on the same market. The mainframes at the time the internet came around was still around. It's still around today. Client server, clearly still around today. Network computing, still around today. And if you don't believe me, remain seated until the end. Internet computing, clearly, around today. So as we go through more cycles, the next one is grid computing. And as I said in my previous slide, again, around today, grid computing itself has become a little bit more of a niche market perhaps, but as I said, grid infrastructure is still around today, and grid computing was a little bit more centralized than the internet computing, and that makes sense if you are an enterprise or a company, because you don't want to have all your data floating wildly somewhere in the internet. You'd like to have it been hosted, computed, and managed in a more secure way, and centralization helps with that. So as I said before, the grid computing time had an idea of having a hub in form of a database or supercomputers, and that went well for the time it lasted, because shortly thereafter came along cloud computing, and cloud computing is exactly the era we are in right now. Cloud computing is again going back towards a more decentralized way, but if you think about it, when cloud computing came out, there were maybe 1, 2, 3 big players, and those big players would have given you a public cloud, and if you had chosen to go to this public cloud, well, then you arguably would have been decentralized, because the cloud in itself was decentralized, but one vendor owned it. So now you see another aspect here. The decentralization and centralization level that we talk about as we walk through this market development has shifted. It was very centralized in the full meaning of the word, and for cloud computing, especially in the early years, it was still centralized, except the cloud in itself is not centralized at all. It's a conglomerate of compute resources, storage resources, and network resources, and so forth. So cloud computing is right in the middle between decentralized and centralized, but if you want to extend the level of centralization, then the next step in cloud computing should consequently be multi-cloud, because that would be then decentralized by both levels. The one level, you have a cloud, but you can also choose between different vendors to run your workload in the cloud. So in the end, after each of these cycles, you end up with more innovation and more solutions. And that is how I have found the market develop in multiple areas. You could do a similar run through for database and database technologies that have been considered en vogue or hip or trendy at some point and were not a few years later. And the opposite holds true as well. There's other battles, however, that you need to think about when you work in the area, in the IT market, and or specifically in the database market. And these areas are important, or these battles are important, because as you speak to customers, as you speak to partners, even as you speak to your colleagues in your company, some people may have different beliefs of which computing trend, technology, architecture is the best for a given solution. Let me give you an example. Let's assume you set up a new system. There's 2 decisions you need to make. Do you go best of breed, or do you go best of suite? Best of breed basically describes that for every layer, every piece in the architecture, the application server, the web server, the database, anything that connects in between, you choose the best solution in that specific layer, in that specific field. That would be best of breed. Instead, you could also go and say, well, I don't want to make so many individual decisions, as we spoke about before. Decisions need to be made at some point, so you need to evaluate those. So, as you don't want to make so many individual decisions, what you could do is you can just buy a suite or a suite, meaning to say you can buy a fixed offering from 1 or 2 vendors. Sometimes we have converged systems, hyper-converged systems, or you have engineered systems, for example, in which you choose everything from one vendor only. That is all, in a way, best of suite. Whether you make this one or the other decision is a little bit up to you. So is the choice between SQL and NoSQL. Who of us doesn't know that battle, huh? How many times did we discuss with customers, partners, or your friends, whether it's the relational database that will solve a problem better or the NoSQL database? And these are battles that exist until today, and they will probably exist for a little bit longer, but they may be influenced by some changes coming up. Another one of those would be shared nothing versus shared disk. Again, one of those battles, what is better to scale horizontally, a database in particular, or other systems that need scaling, but typically derives from the idea, how do I best horizontally scale my database? And last but not least, and that is rather young, but it's now becoming a battle more and more, is do we have our data on premises or do we go to the cloud? And if we do go to the cloud, which cloud do we choose? So they are these latent battles, but in the greater scope of things, we'll have to find out, and we will do this in the end of the presentation, how much do they actually matter? Because depending on how you weigh these battles, when you produce a new product, when you plan a new product, when you plan a new project, when you speak to customers to convince them to do a new project, well, in all these cases, you need to find a balance in those. Perhaps, we'll see. Let's first go into some data and facts. And as I said before, the market develops in the cycle, and in the end of multiple cycles, you always end up with more innovation, more choices, and more solutions. Now, most of you would initially think, well, this is a good thing, right? More is better because I have more choices. Not quite. Look at the cloud market. As I said, in the beginning of the cloud computing era, we had 1, 2, maybe 3 big offers, meaning 3 big vendors that offered a public cloud. I don't want to name them, but you can assume that 2 of them started with an A, and then others came along at the time. So this is good because this is a limited choice. Nowadays, we have a few more than just 3. Here I have symbolized 1, 2, 3, 4, 5, 6, 7, 8. I could have probably found a few more. I don't want to diminish the work of other vendors. That's not the point here. The point here is that there is a handful, probably more so 2 handful by now, public cloud vendors, and that is a good choice. You can now make a good choice. Instead, if you look at the NoSQL database management systems, the NoSQL org, it was called at one time, but the NoSQL site that I found here, they basically list more than 225 NoSQL databases. This is what I call a rich choice, and a rich choice makes it harder for consumers, but as well as for companies, enterprises, managers within these companies to make an informed decision. Because if you really want to make a decision on which NoSQL database to use, you would have to review quite a few of them, even though you can categorize them in memory, document-based, key value pair-based, and all sorts of combination of things. But in the end, you have quite a few databases to review. And this makes making a decision a bit difficult. The same happens actually when you choose toothpaste. If you go to a toothpaste aisle in your supermarket, you find a lot of toothpaste, different brands, and within each brand, there's even different flavors and different things that they do. This is the same with NoSQL databases. In the set of NoSQL databases, there's different flavors, different purposes, but to find the perfect one for the purpose you are trying to solve, it may get a little bit difficult, and you might as well choose by random basis or influenced by others, which is fair, but decisions don't get much easier the richer the choice is. It can actually lead to especially individuals and consumers not making a choice. That's called the paradox of choice, if you'd like to look it up. It's a bit simplified, but it eventually says that too many choices leads to sometimes a lack of making a choice. Or I could make a very concrete example. If you go to a restaurant and you choose and you see the menu and you have difficulties choosing, some of us would just look at the waiter coming by and say, I want that dish. That's a way to make a decision. Is it the most informed decision? Probably not. Now, other data that needs to be considered, at least when you are working for bigger companies or you are presenting ideas to bigger companies, should be market data. And there's multiple research companies that provide market data. IDC is one of which that Oracle works with. We also work with Gartner as well as Forrester. but I happen to have access to the IDC data, and this is some of the excerpts out of this data. So thank you, IDC, for providing us with this information. And as I look at Oracle, Oracle operates in the database market. Now, it's very important to understand, and bear with me as we come to very important conclusions out of this. It is very important to understand that there's actually, even by IDC standards, two database markets. The one that you see on the left is the one that we mostly care about if you work for Oracle. It's the Worldwide Relational Database Management System market. Note the relational database here. On the right side, from my perspective, you have the Worldwide Database Management market. Now, these two differ not only because I have the 2018 number and the 2019 number here, both of which show this share snapshot at the time, and I didn't have any younger data for the relational database market at the time. But the difference between those two is that the worldwide database market is actually a bigger market that that includes the relational database market completely. So the database management market is the relational database market plus all the other databases. In terms of revenue, and then consequently in terms of market share, the relational database management market in 2018 had a revenue total of $36.5 billion US dollars. Out of these revenue-based numbers, Oracle was found by IDC to have a market share of 40.5%. Now in 2019, and looking at the worldwide database management system market, that market is bigger. It's in 2019, it had a size in terms of revenue of 49.3 billion. But remember, the database management systems market does include the relational database market, so we would expect it to be bigger. But as Oracle is majorly considered to be a relational database market player, we do have some other solutions, but that's what we are known for. The share of Oracle in that market, in that wider database management market, is not naturally smaller. It falls down to 28.5%, even though you can see the numbers here. The revenue is nearly the same that we considered, or IDC considered, for having that share. So in both years, roughly 14 billion revenue were made by Oracle with the relational database or with databases in general. But, as in the relational database market, which is smaller, this is a higher share than in the smaller one. Those numbers are still good, even though, Microsoft has 30% in the database management system market. There is another market in which Oracle and a lot of other companies are these days trying to operate, which is the cloud market. And again, there is no such thing. IDC, for example, combines a worldwide public cloud infrastructure as a service market. Note here that it says public cloud infrastructure. This is what you and I would associate with the cloud, the Amazon cloud. It's the thing where you can go and request a compute resource, an instance, run it and operate within it, which is your compute power, and you can put whatever you want in that Amazon instance. For example, you could run a database in it. But there is a definition for this market, which is called the Worldwide Public Cloud Infrastructure as a Service market. And this is on the left side here, the 2019 share snapshot. And you can see, not surprisingly, that Amazon dominates that market with 47%. No other player, it's not an absolute domination, but no other player in this $49 billion market by revenue. No other player is bigger than Amazon. Even Microsoft is significantly less big in this market. It's only 13.1%. But it's only a $49 billion market. And I will say, according to IDC, Oracle is listed under probably the rest of the market. We do not get listed in this market as a major player, which is why Oracle is a little bit shaded out there on the bottom right. However, there is another market in the cloud area, which is important to find and to understand, which is the software as a service and cloud software market. So here, the idea is not to give a compute instance to a customer, but give the customer a fully software package via the cloud, so software as a service, and cloud software to the customer. And that market is way bigger than the cloud infrastructure as a service market, multiple times bigger. As a matter of fact, in 2019, this market had a total revenue of 185 billion, roughly 184.4 billion US dollars by revenue. So playing in this market seems much more interesting because as you can grow in this market, and Oracle is actually a player in this market. In 2019, it has grown in this market from whatever it was, 12.6% from 2018 to 2019. But what I'm saying is in this market, where there is a lot of other players collectively referred to as the rest of the market, this is a market you want to be in. This is a market you can grow in. You can grow in the other market as well, but the market is much smaller. So having a huge domination, a small market, might potentially be less interesting than having a smaller portion of a much bigger market, because that allows you to grow out. And this is then leading us to possible conclusions. Possible conclusions means, and I have a little message here, let me check this right quick. Okay, this message is first of all in Spanish and probably more so to other attendees as well, so I ignore it for a while. Let's come back to the possible conclusions. So one possible conclusion out of the last two slides that I've shown you with the market data is that if you look at the two markets combined, the database and the cloud market, then one possible conclusion is very clear. Amazon is trying to grow into a $50 billion market. Which market would that be? The database management system market. Remember, the bigger of the two database markets, the one that had 49.3 billion revenue in 2019. That is the market in which Amazon is actually going into, because they're developing more and more databases on the Amazon cloud. They are part of other markets, but in this one they are growing into. Whereas Oracle is growing into a $184 billion market, and it has established quite some ground there, which is shown here on the right. Now, the question then is, why would Amazon try to grow into a market that is much smaller than the software as a service cloud software market, in addition to trying to grow in that one too, but they are further away from doing so? Because it's not about the infrastructure. Amazon has a great domination in the infrastructure public cloud, but has a smaller one so in the database management market that is moving to the cloud, as well as the software as a service and cloud software market, for which there is not a good angle yet for Amazon to move into. So why would we want to do this if we were Amazon? Because it's not about the infrastructure or the database for that matter. The database of the application is a vessel. Well, more so, the database is a vessel for data that the application needs. It's really about the data. And the reason for this is there is an idea that was first developed, or the term was first coined by Dave McCrory in a blog post that I've listed here on the bottom right. There is an idea called data gravity. And I cannot explain it entirely in this presentation. I have provided you the links to look it up. But data gravity basically describes the fact or the ability of bodies of data to attract application services and other data. As I said, it's not the infrastructure that matters. It's not even the database that matters. It's the data that you can store on the infrastructure, that you manage in the database, and that the application uses. As you move your data in the vessel database or to another infrastructure, your application is likely to move alongside with this, but also it means whoever has the data will attract, and that's what data gravity describes, whoever has the data, wherever the data resides in more generic terms, will lead to attracting more application services and other data. And that is where the companies are all after. Whoever wins in the cloud battle in the cloud market has a great idea of data to manage, but also has developed a great amount of data gravity that then inevitably, according to McCrory, will lead to other use cases around that data. And that's why you see the development as it is right now. And if you don't believe me, you may have noticed that Oracle has changed its own mission statement accordingly. There was a mission statement before, but Oracle's new mission statement is, our mission is to help people see data in new ways, discover insights, and unlock endless possibilities. So this mission statement is built around data because the market is building around data, or is about to build itself around data, and developments that you see will surround data. So then the question is, what's next? Clearly, as data becomes more important, old battles eventually will subside. And that is the first trend I'd like to offer today for discussion. And the trend is different from data and facts. As I said before, data is data that we see and is retrospective. We know what the revenue in the IT market was in 2018 and 19. So that is data. That data was extracted from information, all the revenue numbers. And nowadays it's a fact that in 2018 or 2019, Oracle, Microsoft, and so forth had a certain share in these markets. We know this for a fact because it's retrospective. But as with all retrospective data, you cannot make predictions necessarily based upon it. You have perhaps the ability to conclude some amount of this data, and that's what we did in the conclusion. And now we come to the trend section. That's why we're looking at what's next. And we're looking at it, so to say, well, if our data is correct, and we assume it is, and the facts are correct, and our conclusions are correct, well then, what does that mean for other developments? What could we derive from this, even though there may be an amount of uncertainty or discussion about it? And one of the ideas that I have here is that old battles will subside. So there is an immediate trend that we actually already see to some degree, by which most of the vendors who had battled between best of breed or best of suite, NoSQL or SQL, shared nothing or shared disk, or on-premises and cloud, most of the vendors who would like to participate in the market of the cloud, in the market of SaaS, software as a service, and in the market of databases in those two areas, well, most of these vendors will eventually offer both of these battlegrounds. So in other words, vendors will go and say, I will offer you a best of breed if you really like to on my cloud, but I really have a suite solution, and I give you a well-defined solution to your problem. And if you ask me, there is an idea to use a suite because sometimes it helps you to avoid worst of weaknesses. If you have best of breed, you still have to look into each solution. And even though each solution is the best in its own class, that's the best of breed, in combination, you need to make sure that there is no weakness, specifically in the terms of security. If you have multiple solutions layered up, you need to make sure that each solution provides the same level of security to have the whole system provide the minimum required security. If you fail to do so, you may run into a case where you have the worst of weaknesses, meaning to say one of the solutions isn't secure enough. It may jeopardize the security of your whole system, but more so importantly, it may jeopardize the security of your data. And remember, data is what we are after here. And clearly for SQL and NoSQL, companies will offer both, and also for shared nothing and shared disk and on-premises and cloud. You don't believe me? Let's have a look. The next step after identifying a trend perhaps, or thinking that there is a trend, I at least look at the status quo. And for what I have discussed so far with you, I think there is a few things that I can say are already clear, have already been surfaced as a trend. The cloud is here to stay. Remember my cycle idea, my upward spiral? In the end of that spiral, in the end of the cloud computing, multi-cloud computing spike there will be a set of public cloud vendors. I don't know which ones those are. If I knew who would win a battle in the cloud war, I probably wouldn't be working for Oracle anymore, but enjoying my retirement life in a nice place, perhaps in somewhere in Latin America. But I don't know that. But what I do know is that a set of public cloud vendors, and I think we all know that, will eventually be offering public clouds. There may be a few more, but remember that the barrier to entry in this market is already very high. The established vendors have put a lot of millions of investment into their respective clouds. So for a new vendor to come in, unless it's a niche cloud for a purpose that we haven't seen yet, which could be the case given the market development, but unless this is the case, to offer yet another public cloud, you would need a lot of money and a lot of investment pre-up to gain in that market. So I'm not saying it's impossible to do that, but the companies who can potentially do that are probably lesser and lesser so, because investments in the current infrastructure is already very high. And I also said that vendors will offer deployment choices, and they will. IBM, for example, was the first one after IBM of years saying we have shared nothing, picked up shared disk. Multi-attach on Amazon Elastic Block is also shared disk. Amazon didn't have that before. So even in the world of Oracle, we have now both. We have Oracle RAC, which is the shared disk approach for scaling, but we also have Oracle sharding. So if you want to have shared nothing or shared disk, those of which you can do with Oracle. You can eventually do this with other vendors. But what I'm saying is the battle has diminished, has disappeared, because more and more vendors will simply offer you both of the solutions, no matter which side you're on. And the same goes for the battle between on-premises or cloud. From day one, Oracle announcing having an Oracle public cloud, very shortly thereafter, at least, we also announced that we will have a public cloud on premises in your data center. In Oracle terms, that is called Oracle Cloud at Customer. That was one of the developments Oracle had right from the beginning of the Oracle Cloud. And in the time, other players didn't have it. Amazon didn't have it, maybe Google had an idea for it. Nowadays, all other vendors, Amazon, Azure, and Google, as listed here, have picked up on this idea and have developed the same. So there is some, following the market trend idea that goes either way. Now Oracle has set a trend that others are following now, whereas perhaps Oracle came a little bit later to the cloud market than the other three listed here. Just so you remember this, Oracle has always offered a deployment choice. You can install Oracle on commodity hardware or engineered system on premises, where it's mostly manual. But if you want to move to the cloud, there's a variety of database solutions that Oracle offers up to the autonomous database. So this is the trend, perhaps, that Oracle has set. The question now is, where does autonomous database range? We'll come to this in a minute. Now, for SQL versus NoSQL, I found a very interesting survey here listed on the top left. A database trend linked here on the top left. It's a nice survey, and it asks hundreds of developers, engineers, and software architects, dev teams, and IT leaders at Developer Week how they would rate certain aspects between single instance, multiple instance, multiple databases, and so forth. So the idea of the survey was to find out what is the database trend in 2019. Now, this is a trend, and it's just a data point for me. I'm not saying this is the all truth, but it's a good idea that this survey has surfaced. Bear in mind, though, this is a survey based on hundreds of people, which is good, but all these people were asked at Developer Week, so they have probably a very common mindset. You've got to know about this, because to derive data from this and to derive information from the data you get through the survey, you need to bear in mind where those people were asked and what your ground amount of people is. But there are some interesting outcome here. For example, who uses, and there's a typo here. So the first column, the second column from the left should have most popular databases. And the most popular databases, according to the survey, was MySQL. So the headline there is inversed. I will correct this when I upload the slide. I don't know how that happened. But this headline here, single database versus multiple database, is answered in the third column from the left, where most of the surveyed people said, we have multiple databases, we just not use single DBs, or in other words, there is a good number of databases that we run. They are dedicated use, but we have multiple of those, so we not only rely on one database. It's still good. The single DB use case was 55.7%, but this is one of the outcomes. The last column then here, and you can go through the survey in detail as time permits. The last column then would say, what is the most time-consuming database management task according to the survey? And I'm sure you can't read it here, although I can walk you through it, but monitoring was mentioned, backups was mentioned, space management was mentioned. But take a step back like I do now. What is really interesting on this diagram is that it's very colorful, meaning to say there's a lot of areas which different people named as being the most time-consuming database management task. Why is that important? Because you could interpret it in a way saying, well, a lot of work is to be done across all these multiple databases, at least across the popular ones, because we know the popular ones are MongoDB, Postgres, and MySQL is the most popular one. So you got to see these answers in correlation, because if that survey is indeed true, and you consider my market cycle idea again, you might see that, you know, whether you have multiple databases or you rely on one, may just be an idea of the cycle in which you are currently in. Maybe right now people prefer multiple databases, but eventually they will see on the right side what's going to be happening. Each individual database has a lot of management tasks that need to be gone through. So maybe there is a requirement for change. And that is why these surveys and market trends are so important, because they may predict a new cycle, a next cycle in the market. I will be done in 5 to 6 minutes here, but what I can see, and Oracle has seen for that matter, is that there are some foreseeable database related developments that you can actually see right now, and some of which can be reasoned by the data that I've just presented. One is there will be higher demand for converged databases. I'll explain what that is in a minute. And I also believe that autonomous database solves a good problem in this area. And data-driven applications and data-driven application development will be an upcoming trend. So I'll walk you through this right quick. There's multiple other presentations why use an Oracle database, for example, that I have on my slideshare that I will elaborate on those in more detail. But what we have seen in Oracle, and therefore have developed accordingly in our database, is that use cases are converging. Take your mobile phone. Phone calls, messaging, photos, used originally to be different use cases, originally required separate products. Nowadays, they're all part of a smartphone, and I believe you have a smartphone as well. Similarly, machine learning, JSON, blockchain required separate databases. Nowadays, they are all part of a converged database, more precisely part of an Oracle converged database. And these use cases converge on one device or on one database for good reasons, because it's much easier for developers to innovate faster on a converged database. It's dramatically simpler for developers to invoke an extended SQL to execute, for example, machine learning graph or spatial, blockchain or Internet of Things in one converged database than it would be to having the data for it in all different databases, potentially having to move data between those databases and execute the individual tasks such as reporting or machine learning in different databases. This is much slower, much better to have this all in one converged database. Also because, and that is what this survey seems to have revealed, also because a single purpose database or single purpose databases tend to spread with business demands. If you go down the route to have a single purpose database for all the different tasks you need to make use of your data, you will end up with way more databases than you perhaps had originally planned in your environment. May it be in the cloud, on your data center in multiple clouds. The Oracle strategy, however, would be to run a converged, open Oracle database for multiple data types and multiple workloads. The multiple workload part isn't new. Oracle database has supported OLTP and warehousing for the longest time. Now we converge other use cases such as JSON, graph, spatial, machine learning, all on the database that you already know. So you can easily make use of it. And then we put this whole idea into the autonomous database. Why would we do this? Because the trend is to make use of data. The trend is not anymore to manage databases or the vessels that hold the data. The autonomous database solves exactly this problem. The autonomous database is based on the Converged Database, especially starting with Oracle Database 19c. But in the Oracle Cloud, it provides self-driving, self-securing, and self-repairing. So consequently, you can benefit from all the good that the Converged Database would give you, while at the same time, you don't necessarily need to spend a lot of time on managing it, because the autonomous database will do this for you in the Oracle Cloud. That isn't to say this is the only way to benefit from the Converged Database, but it is clearly one and an easy way. Now in this context, I want to briefly speak about, are we too late, too early, right on time, or spot on with the solution? Because that will eventually, the timing will eventually determine whether a solution that you offer as a company is successful. This picture you saw before, it's this symbol, this picture that I used for network computing. Now, you may not remember, but that specific network computer was a diskless desktop made by Oracle Corporation between 1996 and 2000. Clearly, the idea of having a network computer connect to something in the internet, in the cloud, or something beyond what you can see as a network connect was too early at the time. And yet again, today, the same idea is kind of on vogue because there is a lot of Chromebooks out on the market. My kids recently got one when the school started, because our school nowadays is using Chromebook for online learning. And Asus, just one example, there's multiple others, no preference here. Asus brought out a Chromebook right on time. They saw the need, they saw the development, they brought it out. That's perfect for consumer good. The question is the Oracle Autonomous Database right on time? No, I think it's spot on. Right now, customers are in this cycle where they need to make use of the data, at the same time need to reduce the amount they spend on managing the vessel that holds the data, speaking the database, and are adapting more and more to the idea of cloud and multi-cloud. So having an Oracle Autonomous Database in this cycle of the market is probably spot on as far as I can see. And in this context, there's lately been released a new autonomous JSON database. So you can see here, we are actually going the route I am laying out here for you. Coming to the end of the presentation, I think we have established that data is what matters the most these days. And every database company and every cloud-oriented company that also offers databases perhaps will be looking into getting hold of the data and manage this data for you. There is no exception across the board. Amazon, Microsoft, they all have the same plan in the end. The question is, who has the best solution? And the Oracle database has many solutions to either manage your data, but also, and that is any data, but also to extract data, refine and integrate it, persist and process it, and then use it for analysis and prediction, so you can get more out of your data, whether this data is in the Oracle Cloud, anywhere else, or ideally in the Oracle database, for which we have a deep integration as well as with our products. The idea is to use this data, and Oracle has a bunch of technology for that, to help you power innovation, boost efficiency, and reduce risk. Reduce risk is also very important. I'm not a security expert, but in this process where you operate on that data, you need to make sure, as I said before, that you are securely handling the data, you make this process disruption-free, and then you can actually produce limitless predictions, way more than I can do in this presentation with you today. Now, I mentioned before, the need for analyzing this data is big. However, not always do you need to have what I spoke about and illustrated before, an analytics warehouse. Sometimes you have data and you just want to review this data, browse through it in a very swift, efficient way. That is where Oracle Apex comes in. Oracle Apex is a data-driven low-code apps which allows you to take the data in an Oracle database, I will admit, and analyze it. You basically have the data, you run a nice visit and some input, and you can analyze this data in no time in a graphical manner using Oracle Apex. That's where Apex and the orientation for development comes in here. And that is what I said before, application development based on data, data-driven application development is what's currently trending. And this is exactly then my summary. Based on all these observations that we made today, or that I've made over some time being a PM, and the possible trends that we discovered out of it, observations, conclusions, trends, I hope I have shown you that the cloud is here to stay, and you should probably look into getting familiar with the set of public cloud vendors that you think will be staying. But also have a look in Oracle's Converged Database, because I kind of have the feeling it might be part of the next cycle in the market. Clearly, the autonomous database is right there, right now, so it's a good opportunity for you to have a second closer look, and maybe in a year from now, what I had said today as a trend or as a conclusion will actually be presented as a fact or as data. What is trending right now is data-driven application development. That is not only the case for Oracle. You look outside of Oracle with other database vendors, some of which I've mentioned in the course of this presentation, you will find the same trend. So I'm kind of clear that this is not something that Oracle has set the trend for, but this is something that the market has produced as a trend, whereas the autonomous database is clearly a trend that Oracle has set, and we wouldn't have been the first time it wouldn't have been the first time for us setting a trend. With that said, thank you so much for staying with me. I'm not right on time, but not too much later. If you have any questions, I don't see any questions in the Q&A. If you have any questions as a follow-up to this presentation, please do not hesitate to reach out to me either via email or one of my social media presence. But until then, enjoy the rest of your day. Thank you for staying with me, and back to you, Miguel.